All right, this is a brief overview of the rocket launch system handheld unit that you would use to control the entire rocket launch system. The components on the front are the arm switch here, which is guarded. We have a joystick that has a clickable Z-axis for control, a guarded launch switch with a lit bezel, an SD card, and a multicolor screen. These two dots are lined up with switches underneath for reset and programming if we ever need that. So to turn it on, we push straight down on the button, we get our splash screen, and we go to the main menu. Along the top of the display, there are 5 boxes here, and that's the firing chain. Each one of those conditions has to be met before we can send the launch command to the pad. The first thing is charge. That tells us that the battery on the pad unit is properly charged. Continuity is the second one. That tells us that there's electrical continuity across the igniter leads. Arm is when we turn on the arm switch. Trajectory tells us that we have a valid trajectory loaded into the box. And launch happens as soon as we hit the launch button. On the upper right, there's a battery indicator. The top green bar represents the controller battery level, and the bottom bar represents the pad unit battery level. This represents that we have a good antenna connection to the pad unit, and the SD card symbol shows that we have good communication with the SD card. A sample rocket has been loaded by default. You can see the selected rocket, the rocket mass, the rocket area, and then the selected engine. So we'll go ahead and change that for this example. So we'll use the joystick to navigate over selected rocket, or select rocket. And the way it's organized is by manufacturer. When we click on a manufacturer, we get all of the rockets available on the card under that manufacturer. So I'll use the Estes Mongoose as an example. Selected rocket is Mongoose. We have a hexagonal parachute for a recovery system with a diameter of 0.3 meters. Now I'll pick our engine for the launch. Go to select engine. Now same interface here. If I choose Estes and then go down to an engine that I want, I'll choose the C6. You can see on the lower right here, there's the thrust curve for the C6 engine that came right out of the manual for the engine. Maximum thrust is 14 newtons, and it'll burn for 1.86 seconds. And this is exactly what the simulation will use to calculate the trajectory of the rocket. We can also tell it how many engines we have clustered on the stage. We can do a 2, 3, or 4, but we'll stick with the 1 for this example. Last, we choose the delay, and we'll make this a C6-5 engine. So now at the bottom of the screen here, you can see C6-5 with the selected engine. Back to the main menu. Now this system uses sensors in the pad unit to send parameters about the environment in real time. It senses what the temperature is, what the pressure is. It converts that to air density, which is 1.29 kilograms per cubic meter, also used by the simulation to determine the trajectory of the rocket. Launch rod length, the wind speed you put in based on what you can pull from local weather sources. And then the upwind distance available represents the upwind safe area of your field, and the downwind distance is the downwind safe area of your field. So we figure we're launching it and we have 200 meters upwind and 200 meters downwind to play with. We'll go to the main menu, and we're ready to do a launch simulation. So if we go to trajectory, the computer will take all the parameters that we loaded and build a simulation of what this rocket will actually look like. The burnout occurs at 79 meters. Apogee is at 164. 156 meters, the parachute will deploy at 18 meters per second. And this white line represents the parachute track, and it will end up landing 29 meters behind us. Its maximum distance upwind was 122, and you can see that this entire flight took place within this green bar. And that green bar is what we just set with the upwind distance and the safe downwind distance. So this would be a good launch. The other contingency we have to worry about is if the parachute doesn't come out, we can launch, we can actually run a ballistic calculation. Same calculation, same parameters, but this is assuming that the parachute never comes out. So 186 meters, and now the rocket's falling straight down and lands 33 meters ahead of us. So both of those conditions look good to me. It never leaves the safe area, so now we're ready to launch. So now we've fulfilled, we have good charge on the pad unit, we have continuity, we have a trajectory. All we have to do is arm the system. And now we can hear that the pad unit is armed. There's a red light flashing on the back, and there's a red light on the launch button telling us that when we push it, the rocket's gonna go. So when we push the button, the rocket should launch. The system puts about 5 amps across the igniter, where a typical out-of-the-box system would give you about 2 amps. So this is a much more powerful launch. It is instant when you push the button. The arm switch is still on, but it has disarmed itself. And the reason for that is if you're launching rockets, especially with kids, and the rocket goes and you drop the launcher straight down onto the ground while it's still armed, it could have also pushed the launch button. And when you go retrieve that rocket, reload it, put it on the pad and hook it up to the launch system, there's a potential that as soon as you hook it up, the rocket will ignite right where you are, right into your face.
I really see the danger in this system, where if I accidentally launched the rocket, kept the key into it, and then dropped it, and it fell face down, pushing the button down. When I went back to reload that rocket, as soon as I connect the leads back together again, this thing could definitely launch into my face. All the more reason to have an arm switch that disarms once you push the fire button.
This requires that you come back to disarm and then rearm it. So it eliminates that possibility as a safety feature. Okay, so we could continue to trade in and out different rocket motors and different models. But if we're done here, we go to main menu. And if we go to shutdown, I'll show you the way we recharge the lithium-ion battery inside the unit here. So we can take any standard 5-volt charger. There's a jack on the back here. Go ahead and plug that in, and there's a charge controller inside. And here it shows you how much battery is remaining on the controller battery and how much is left on the pad battery. So you can actually see the controller charging in real time. So I hope you enjoyed this overview, and we'll see you out in the field.